Well, good morning and welcome to Nani Notes. And also, happy Valentine's Day. Hey, let's have some fun today. This is a continuation of a previous exercise where we first learned how to, convert a parabola from standard form into HK form. Now, back then we said, we're just going to use examples where the leading coefficient, the x squared term is 1 or a equals 1. I said, now it's time for when a is not equal to 1. Let's just do 4 examples, okay? Let's get to it. All right, first, let's review the concept. Here's a parabola. Here's just a regular old parabola. Where vertex could be anywhere. Let's put it at the origin for now. Now, if I put the vertex there at the origin, that's y equals x, or y equals x squared. 1 squared is 1, 2 squared is 4, 3 squared is 9. We can see that. But we know that if we move or change this coefficient, we make it bigger, it gets steeper. That's y equals 2x. 2 squared is 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. So we're up there at 2, 8. And we remember doing that. We get steeper, 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 y equals 3x. We could go the other way as well. Maybe, okay, we're less than 1 here. We get that wide parabola. What if we go negative? This is y equals negative x. The opposite of x, or negative 1 times x. The coefficient, negative 1, is pointing down. Remember, all those negative coefficients are pointing downward. It can also get steeper like this. Now, just like before, regardless of that coefficient, we could take that vertex and we could place it anywhere. We can do this with standard form, but we're going to use HK form. Remember, all we have to do is know those coordinates of that vertex, and we can place this parabola. So, turn that frown upside down. Let's get to it. Are you ready? The answer is yes. Okay, here we go. Here's our first example. Standard form where a, the leading coefficient, is not 1. We remember our perfect square trinomial form. I'm not going to do the FOIL thing in this video. You guys have seen that before. We've gone over it. But remember, we've got, in this case, a minus b, that quantity squared, we generate a perfect square trinomial. The first term is the a squared, the last term is the b squared, and the middle term is twice the product of the 2 terms. So the way we crack this puppy, we're going to take this and we're first going to factor out the 2. Okay? And it looks like that. Now, gave you an easy one here where we've got even numbers on the b and the c term. But now watch what happens. We're going to treat this just like we did the last time. We're just going to focus on inside the parentheses, that part of the trinomial. Let's look at the b term of negative 6, and we'll take half of that. Remember that? Take half of b. Half of b is 3. Oh, I could be busting a rhyme here. And I know that if I were to expand this in the perfect square trinomial form, I know inside the parentheses I've got x squared minus 6x plus 9. Now, here comes the next tricky part. This equation looks really good. We've got the h. The h is the 3. We need the k. Now, we're trying to adjust to get back to our original equation up here. But you got to remember that this 9 is not a 9, it's really an 18, because you have a leading coefficient of 2 here. Now, you don't have to write this out, but you just got to remember that's 2x squared minus 12x plus 18. If I take that 18 and I want to adjust it to 22, how do I do that? Well, I'm going to add 4. So check it out. There is my equation. Heavens to Murgatroyds, this is beautiful. So, what do we come up with? X minus h and plus k. Okay, that was almost too easy, but we're going to have to graph it just to enjoy it. And we're going to graph it a little bit fun, dynamic graph here I just made for you. Why? It's Valentine's Day. Okay, here we go. 3, 4. Remember, the vertex is 3, comma, 4. So we know where that vertex is. I could move this guy around. Say this is 3. Oh, sorry, this is 3, 4. I hate when people interrupt me. But now watch what I'm going to do here. I'm going to change that coefficient, that parabola. I'm going to make it steeper, steeper, steeper. That's the shape. This is the parabola y equals 2x squared positioned at the vertex 3, 4. Nice. So, ready to try another one? Okay, I knew you were. So again, we're converting. We're going to do 4 of these. 1 down, 3 to go. Ooh, now this is a trickster. Why is it tricky? Because a is not 1. Look out here. A is negative 1. Yikes. I'm going to factor out a negative 1. And look what I've got. Now, if I want to be really pronounced, I could put a negative 1, or just put a negative sign out there. I am factoring that negative sign out. So I've got now x squared minus 3x minus 2. Okay, this is really kind of tricky because the signs are what always trip us up. Now let's take half of b. Now I know that my b is 3. Can you take half of b? Everyone says, is 3 divisible by 3? Of course it is. On the set of real numbers, oh, that's 1.5 or 3 halves. Now, let's do this expansion. We remember this expansion. How many of you have memorized your squares? And I know you guys do it for the Pythagorean theorem. You get up to 25 squared in your head, and you all know that 15 squared is 225. If you don't, you got a calculator. And then you can move that decimal point over, and you can quickly see that 1.5 squared is 2.25, or as we say on the East Coast, 2 1/4. So again, I squared what's inside the parentheses. The negative sign applies to each of these terms. So watch out on this one. Watch what we do here as far as making the adjustment. Now, I am going to have to add. I guess I kind of skipped ahead on that a little bit. I'm going to have to add 4 because I need to make this 2. But you see, this is really negative x squared plus 3x minus 2.25. When I add 4.25, I get my c term. I get my 2. Now, you could have written that out if you wanted to. You could have said minus x squared plus 3x minus 2 1/4. And then it would be more obvious that you have to add 4 1/4. So 1.5, 4 1/4. And look at that, getting away from those integers. Be a little more fun, a little more real. So let's see what we can do let's see how that works. Should we graph it? Oh, as one famous Alaska politician once said, you betcha. Yikes. Well, let's have a look at this puppy. Now this is the equation. Well, it's what we've come up with, and we can see we've got a 1.5, 4 1/4. So we're going to be in the first quadrant, but this time I'm going to change the a. I'm going to change the coefficient. This coefficient is a equals 1. I'm going to make it a equals negative 1. This is what negative 1 looks like. It's upside down. Now, if I were to put this at, well, I'm trying to graph this, 1.5, 1.5, about there, 4.25, about there. Now, if you're kind of not sure and you want to verify this is working out, it kind of looks like we've got a few points we could check. I want to evaluate it at x equals -1, and then I'm going to evaluate at x equals 5. Let's go to the original equation, shall we? When x equals -1, let's make that substitution. Whew, watch those signs. That -1 squared becomes a +1 with a negative sign back to -3, well, geez, I don't have to talk about arithmetic. You guys are a bit better than that. But that's what you got. Y equals -2. And check this out. Heavens to Murgatroyds. Y equals -2. X is -1. Y -2. That looks pretty good. Hey, let's check out another one. Let's check out when x equals 5. Because we said we would. Yeah, I just picked those out because they look like they might come out kind of cool. All right. 5 squared is 25. 3 5s are 15. Watch your signs. You've got -25 and 15 plus 2 is -8. -8 on the money again. 5, -8. So that checks out. Gosh, we're having some fun with those parabolas. Later on you'll be doing word problems and you'll look at this. And, we love these usually in projectile motion, and you'll say fun things like, ooh, this has 2 x-intercepts, right? Or maybe you guys have already done that. Let me know in the comments. Here we go. Let's do 2 more. Come on, we're just getting through these. -1/4. Well, here we go. Now, I can factor out a -1/4, which really is to say multiplied by -4. And this is what you got. Your B and your C term become -12 and 40 respectively. And piece of cake, because we all know that half of 12 is 6. It's going to be negative. And we know this form of the perfect square trinomial. 6 squared is 36. When I expand that, that's what I've got. Now, I made this in small print because I don't think you're really writing this down, but you got this far, and you're aware that that -1/4, that coefficient applies to each of these 3 terms. So that 36 is not 36, it's actually -9. -1/4 of 36 is -9. And you're looking at, what is my adjustment going to be? I've got -9, I need -10 to match my original equation. So there's my adjustment, -1. That is just beauteous, Maximus. -1 is my K. My H is 6. Where is this one located? 6, -1. And which quadrant is that? Right, runs with door. All right, well, we'll graph it. Does it have any x-intercepts? I think you already know, but let's find out. So here we go, 6, -1. Now, 6, -1, if I move the vertex, this is 5, this is 6, there's -1. Yeah, it would appear to have a pair of intercepts if the coefficient were indeed 1, but it's not. It's not. It's something more like, it's negative something. Uh-oh, -0.2. Oh, I made these in increments of tenths, so bad banish. -1/4 is actually there. So that would be your function. And you can see this one does not cross the x-axis. Not at all. And you've got your values, you've got your vertex, and it's just pretty. Okay, let's do one more. And by the, I'm sorry, I didn't put the numbers up there. For those that are following in the McDougal Littel textbook, these have been numbers 8, 9, 10, and 15. I'll put the numbers on the in the description of the video and the page number, perhaps. Yikes! Look at this one. Negative 1/100th as a leading coefficient. That is going to be one shallow curve pointing downward. We know it's negative, it points downward. And let's crank this guy out. We factor that out. Again, to factor out the 0.01, you're multiplying by, well, negative 100. And that makes sense. I multiply by negative 100, and now I'm looking at this perfect square trinomial. I'm going to take half of that 20, and I know that that's going to be 10. Of course, I should say half of negative 20. That's negative 10. And when I square this puppy, that's what I get. Yeah, by now you guys got that down. Remember these coefficients. That negative 1/100th applies to each of these terms. What's negative 1/100th of 100? Well, heck, that's negative 1. Now, you don't need to write that gray stuff. That's why I grayed it out. You probably just think that. And right away you can see that is your, well, that's what you need to take negative 1 and raise it up to positive 1. You're going to have to add 2. That's your adjustment. So H is 10, K is 2. Which quadrant? Rhymes with bun. Well, you know this is in the first quadrant. We know it points downward, so we know it's going to intersect the x-axis. It's going to have 2 intercepts. Now, in this case, I just sketched it out for you on Sketchpad, and it's going to look like that. Very, very shallow indeed. And I think that's what we'll do. We'll call it at that. I hope this has been helpful, and keep up the good work, and you'll be doing word problems in no time. So happy Valentine's Day, and thank you for watching Nani.